Welcome everyone to the second lecture on programming in C++. So today we are going to continue from where we left in previous class. We are going to continue the introduction to C++. So in today's lecture, we are going to talk about program control flow. Program control flow means how the programs control or how the statements are being executed one after another. So we have three different kind of program control flow. One is sequential, another one is branch statements, conditional statements, or the third one is repetitive statement or iterative statement. So we are going to learn about them and how they are implemented in C++. Then we are going to identify the techniques for input and output in C++ and how variables can be declared in C++. We can look into that. Control flow is defines how the program is being flowed or how the statements in a program will be executed. There are three different control flows available in any programming. One is sequential, another one is conditional or branching, another one is iterative or repetitive. In sequential statement, all the statements are executing one after another, whereas in conditional or branch statement, we might have this kind of situation. So we might have two roads and we have to choose one of the another. So control is flowing from here and we have two routes and from one of them will be chosen depending on some condition. Uh, so this is conditional statement, wherein sequential statement all the statements will be executed one after another. So this is sequential. And in iterative or repetitive statements, some statements or a group of statement will be executing in repetitive manners. That means they are to continuously repeat whatever statements or whatever operations they are performing, they are going to continuously repeat those statements. So we are going to learn how this kind of control flows are being implemented in C++. So there is no need to tell how sequential statements are being executed. So any statements is a sequential statement if we are not using conditional or branching or iterative or repetitive statements. So let's talk about this conditional branching. So there are multiple ways in which we can apply this conditional branching. First of all, we are going to learn about conditional jump. That means uh, so we have some situation here and we can go here. So in conditional jump, what we can do, either we will go into this circle or we will just jump here. So this is like conditional jump. So the program or the statement or programs is being executed in this particular line, and then whether depending on some condition, whether we are going to move towards this circle or we are going to pass through this circle. So this statement or this kind of statement is represented using this if statement. So what is the syntax of this if statement? So the syntax of if statement is something like this. So we have if. So this is the keyword that is used to represent conditional jump statements. Followed by a binary condition. So what is a binary condition? A binary condition is an expression that returns a bool type of variable. So it is a bool value. That means it will return either true or false, or it can be uh, zero and non-zero. So any non-zero value in a binary condition represents a true value. Any zero always represents a false. So in the if block, that means if starts and ends with braces. So inside the if block, we have statements. Those will be executed if this binary condition is true. So if this binary condition is true, the control will flow through this particular block. If this binary condition is false, the control will move to here. So this is the working principle of if statement. So let's take an example So we have if a greater than b, print a is greater than b. So here, as we can see, if the value of a is equal to 5, b is equal to 10, then what will happen? We are not going to do anything because a greater than b, that is a false statement. So a greater than b implies that 5 is greater than 10. So this is false. So as this is false, we are not going to execute this particular statement. But if we have, suppose a is equal to 10 and b is equal to 5, then that implies 10 greater than 5, and this is a true statement. So when this particular statement is true, so when the value of a greater than b is true, this particular statement is going to execute. So then comes a two-way branching. That means this kind of situation where we have two paths and we must select a path depending on certain condition. For that, we use this if-else statement. So what is the syntax? So it looks like this. If binary condition, the statement or the criteria of binary condition is same, it is a boolean expression that can be true or false or either 0 or non-zero. So if this particular value or if this binary condition is true, the statements within this particular if block will be executed. Then we have else keyword and followed by a block of code. So this particular code will be executed if this if or binary condition is false. So take a look at this example. So here we have if a modular division 2 is equal to 0. So it is basically checking whether the number is odd or even. So if a modular division 2 is equal to 0, we can say that number is even, else the number is false. So now if the value of a is equal to 1, so what will happen? A modular division 2, it will return 1 and this is not equal to 0. That's why this particular statement is going to be executed. Whereas if we have a is equal to 4, so 4 modular division 2 is equal to 0. That's why this particular statement is going to be executed. So this is how two-way branches can be represented in C++, where we can use this if-else statement. It comes, then we have multi-way branching, or not multi-way exactly. This is called nested if. This is also another type of conditional statements where inside a if block, so suppose this is a if block, inside a if block we can have as many if blocks or if else block as we want inside that if block. Similarly, inside the else block we can have as many as if or else block we want. So this kind of structure is known as nested if. So let's look at this syntax. So if binary condition 1, so if this binary condition is 1, we are going to execute all the statements here. So then we are going to check some statement that is binary condition 2. So if this condition is true, this particular statement is going to be executed. If this condition is false, this particular statement is going to execute. If this binary condition 1 is false, then we are going to move into this section. So this is for true and this is for false. So as this binary condition 1 is false, we are going to check a binary condition 3. So if this condition is true, then this particular statement is going to execute, or a set of statements that are inside this if block are going to execute, and else, or if this binary condition 3 is false, then the statements in this else block is going to be executed. So let's look at this particular example where we have checked the maximum between three numbers a, b and c. So to check the maximum between three numbers, what we have done, so we are first checking if a is greater than b. So if a is greater than b, then we have to check if whether that a is greater than c. So if a is greater than c, we can say that a is the maximum number. If a is not greater than c, and though we have already learned that a is greater than b, that means c is the maximum number. If a is greater than b is not true, that means if it is false, then we can say among a and b is the maximum one. And now just compare b with c, whichever is the maximum is the maximum value. So that particular logic is being represented in this particular example. So what happened here? So if a greater than b and if a greater than c, we can say that a is max. Else, we can say that c is max. So let's consider A is equal to 5, B is equal to 2, and C is equal to say 4. So the output should be A, right? So A greater than B. So that is true. So A greater than B, that means 5 greater than 2, that is true. That's why we are going to check A greater than C or not. So A is 5 and C is 4. So 5 greater than 4, that is also true. So now we can output that A is max. Now interesting thing is that only one of these statements are going to execute. That means if this, depending on this condition, either this section is going to execute or this section is going to execute. Similarly, depending on this condition, either this section is going to execute or this section is going to execute. So if we have something like this, say A is 2, B is 4, and C is suppose 9. So if we have a situation like this, then what will happen? A greater than B is false. So then we directly move into here. So these statements are going to be ignored. So now we are going to check if B is greater than C. So if B is greater than C, then we can say that B is the max. If that is not true, if this is false, so then we can say C is max. So in this situation, what is happening? So we have already learned that A is not greater than B. That means B is greater than A. So after that, we are comparing B with C. So what is happening? So we have 4 greater than 9. So that is again false. So as this is false, we are going to execute this particular statement and the output will be C is max. So this will be the output for this particular set of code if we have A is equal to 2, B is equal to 4, and C is equal to. Then becomes a multi-way branching. Multi-way branching means we have a situation like this. Say from one particular flow, we have several paths and we can choose only one of them. We cannot choose all of them. We must choose only one of them. So this is multi-way branching. So there are two different approaches or two different methods in which we can actually implement this multi-way branch in C++. So one is if else if and another one is called switch case. That is that we are going to learn next. So let's talk about if else if. So this is called if else if ladder as well, or if else ladder as well. So what is happening here? So we have a new introduction to else if. So we can have multiple conditions and they will be segregated using else if statement. So it will start with the else if and it will end with a else. So this is not mandatory. So you can either put the else, you can not put the else. It's up to the programmer. If, else if, then else if. Consecutive else ifs will be there and this else is optional. So either you can give it or you cannot give it. So what is happening here? So if this binary condition 1 is true, so whatever statements in this particular if block is here will be executed and all the other statements, all the other statements that are residing in the consecutive if else block or the else block will be ignored. Whereas if this particular condition is true, everything except this particular block will be ignored. That means only this particular block or whatever statements, one statement, two statement, or five statement, whatever statements is here in this particular block will be executing. All the other statements are going to be ignored. Similarly, we can have as many if else if conditions there. If all the conditions are false, then only we can move into this else section and it will print or it will execute if all the conditions are false. That means if this first condition in the if is false, if the consecutive if else if conditions are also false, then only we can move into this else section. So let's take a look at this example where we are going to take the input marks. So we are going to take the input marks and depending on the marks we are going to assign grade to that particular student. So suppose if the marks is say 45. So what will happen? First of all, we are going to check if the marks is greater than equal to 90. So if not, So obviously the marks 45 is not greater than equal to 90. So we are going to ignore this particular statement. So this is ignored. Then we are going to check. So we have already checked whether the number is greater than equal to 90 or not. So if it is greater than 90, suppose if marks is suppose 95. So what will happen? This particular statement will execute, and all the other if condition or else, all the other if conditions as well as the else condition is going to be ignored, completely ignored. So depending on that, what we can say, that's why we have not taken or we have not write here if marks greater than equal to 80 and marks less than equal to 90 or 89. So we don't have to put this particular part because whatever number is greater than equal to 90 has already been checked here. They are not going to be followed here. So that's why we don't need to put this particular statement. So this is enough to check the consecutive numbers. So if the number is 45, what is going to happen here? So else if is greater than equal to 80. So then this particular statement is also going to be ignored because the numbers is not greater than 80. Then we are going to check if the marks is greater than 70. This statement is also going to be ignored because the marks is 45, that is less than 70. Then we are going to check if the marks is greater than 60, and this statement is also going to be ignored because the marks is 45. Now else if the marks is greater than 40. So now somehow our condition is matches with the marks, and then we can say that yes, the grade is T. So this will be printed on the screen that depending on this particular marks, the grade is T. If we have suppose 38, so marks is 38 now. So what will be printed? Grade equal to fail because none of these conditions are matched with the input value, or for none of this or for this particular input value, none of these conditions are true. That means all of them are false. That's why this else part is going to be executed and the output will be grade is equal to fail. So now we are going to learn about another multi-way branching statement, that is a switch case statement. Now this is somehow different from if else if statements. First of all, we are going to look at the syntax of this particular statement. Then we are going to talk about the differences between if else if and switch case statement, and what are the problems in switch case statement and how to rectify those problems. So switch case starts with a keyword switch where we have to put a control variable. So in other cases, in all the if cases, we have to put a binary condition. But here we have to put a control variable. This variable can be anything, not double. So it should be int and it should be char, not double or float. So we can only put integer and character in this control variable. So if we have a variable say int x is equal to say 5, so we can put x here. So the control variable can be x. If we have a character variable, that also can be a control variable. But if we have a float variable, say float f is equal to 2.5, so this is not allowed in case of switch case statement. So this is the one difference. This is the first difference, that in switch case statement we cannot allow, or switch case statement actually doesn't support int and anything beyond int and char. But nowadays in some high advanced C++ compiler, double is somehow supported, but in actually original C++, int and char only are the supported control variables or control data types in case of switch case. Then inside the switch block, so this is the start of switch and this is the end. So inside this switch block, we have some cases. So we can have as many cases as we want, and also we can have a default case as well. So I will come to this default case later. So let's talk about these cases. So these cases will be some value. If it is an integer, so these values will be some integer values like 1, say 2, say 3, and so on. So if what is happening here? If this control variable x is equal to 1, so what is checks? It's only checks for the equality. That means it checks if x is equal to 1, then only whatever statements here are going to be executed. But that is not true. What is happening here? Whenever a case is satisfied, all the statements afterwards are going to be executed. That means if the value of this value of x is 1, so all the statements are going to be executed. If the value of x is 2, suppose, so from here all the statements is going to be executed. This statement will be ignored for the value of x is equal to 2, but for later cases all the statements is going to be executed. But that is not what we want. So this kind of problem where all the statements are going to be executed regardless of whatever the value, or whenever we have found the correct match for this switch or control variable, all the statements afterwards are going to be executed. This problem is known as fall through, and the solution to this problem is the use of break statement. So we know that from C, we know that what break statement does is actually breaks out of a certain block. So it can break out of so break statement can break out of switch, as well as it can break out of loop that we are going to learn in a short while. So let's talk about this default now. So what this default does, if none of these cases or none of these values are equal to this control variable, the statements in this default block are going to be executed. So it is similar to the else block in if else ladder. So if all the statements or all the values are unmatched or not matched with the x value or the control variable here, so this particular statements or the set of statements that is in default block is going to be executed. So let's just use this break and rewrite the syntax of the switch case now that doesn't have a fall through problem. So this is the new syntax switch case with the break statement. So what is happening here? So we have similarly or same as before, we have the switch keyword, the start, the end, and we have that control variable. Now we also have this case and value, but what is happening here? After writing all the statements that are going to be executed, if the value or control variable is equal to value 1, we have put a break statement. So in every case or after every case, we have put a break statement. So that will ensure that if this control variable is equal to value 1, only the set of statements that are residing in this case block is going to be executed. If the value of control variable is value 2, only the statements that are residing in this particular block are going to be executed. So let's take an example. So here we are going to put a day of number. So suppose this is an integer number. So day number. So it can be 1 to 7. So where 1 will imply Sunday and 7 will imply Saturday. And if someone gives the value that is not in the range of 1 to 7, suppose 19. So it will print a wrong input. So what is happening here? So we have put this day number uh, as a switch variable, a switch control variable. Then we have this case 1. So if day number is equal to 1, we are going to print Sunday and break. That means break out of this section. So if day number is equal to 1, what will happen? This line will be printed. That means Sunday will be printed. This string is going to be printed, and the loop will break out here. So it will be break out of here. So if the day number is suppose 6, uh, so Friday will be printed. Only Friday, nothing else. Only Friday will be printed, and it will break out of here. But if the we have not used break here, so what will happen if the day number is 6? So it will print Friday, Saturday, as well as it will print wrong input. So regardless of whatever the statements are, whatever the cases are, after finding one positive case or one case that has the value similar to the switch variable or control variable, it will execute all the statements afterwards. But putting this break, we have somehow controlled the fall through problem. Next, we are moving to iterations or repeated statements, sometimes called loop. So in programming terms, they sometimes called loops. So in certain situations, so depending on certain condition, so some of the statements might repeat themselves. So this kind of statements can be represented in programming languages through loop. So before that, we must look into all the parts that are available for loops and that can be interconnected with each other to form an iterative statement. So first of all, we have an initialization step where we initialize a control variable. So this control variable is a loop control variable. So the initialization could be look like this: int a is equal to 1. So this is an example of initialization statement where we have initialized this variable a with the value 1. So now this particular value or variable a can be considered as a control variable. Then we have a binary condition that denotes when or until how the repetition is going to happen. So the repetition is going to happen until and unless a is less than equal to 10. So for example, we have taken this statement to represent this condition. So this binary condition also refers to as exit condition. That means if this binary condition is false, that means when the value of a is equal to greater than suppose 11, at that particular time the loop will stop iterating. So from 1 to 10, for all the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the loop is going to be repetitive. Whereas when the value of a is going to 11, the loop stops. That means it could be something like this. So if we have the value of a starting from 1, so it can be go up to 10 suppose, and then when it becomes 11, the loop terminates. So this is the end condition. So that is, this binary condition is basically the end condition, or you can say it is the continuation. So until and unless this particular condition is false, the loop is going to be repetitive. Then we have a body. So inside this body, or inside this body of loop, we are going to write those statements that are going to be repeated. For example, we have taken this particular statement cout a. So we are trying to print the value of a, and this will be work as a body of the statements. And in the step value or change, what we have, so what we are going to do, we are going moving or we are moving towards this end. So we can either move forward, we can either move backward, depending on what is the exit condition. So this step value is nothing but from this start. So this initialization can be considered as start. So this can be considered as start, this can be considered as end. So the step value determines how much steps we are going to take. So this is the step value. So the step value could be +1, this step value could be +2, and so on. So it cannot be, in this particular example, it cannot be more than uh, say 10. If the step value is 10, the loop will only execute once, because after executing one statement or one time, after executing one time the body of the loop, the step value will change the statement of a, or the value of a to 11, because 1 plus 10 will be 11 if we have this particular step value a is equal to a plus 1. That means we are moving forward. So it could be a is equal to a plus 10. So a will become 11, but for this particular example we have taken a is equal to a plus 11 1. That means we are moving from 1 to 10 in a step of 1. That means 1 will become 2, so a will become 2, then 3, then 4, then 5, then 6, 7, 8, and 9, then it will become 10, and then it will become 11. So these four steps, or these four parts forms any loop. So in any loop, any kind of loop, so we have basically three different loops: while, do while, and for. So in all three loops, we can see these three parts that can be reconstructed or formed this particular loop. Uh, so we have two different type of iterative statements or loop. One is called entry control, another one is called exit control loop. So in entry control loop, the condition checking before entry to the body. That means in case of the body will be going to execute only if the condition is satisfiable. That means if the condition is true, then the body is going to be executed. But in case of exit control loop, first entry without any condition taken. That means the body can execute at least once. At least once. And then before exit it checks for continuation. So if the condition is true, it will continue for the next iteration. So what is happening here? So we have this particular example do while that is comes under exit control loop, and for and while, these two are the entry control loop. So we are going to take a look at the syntax and example as well. uh, so what is happening here? In case of entry control, the body is not going to execute if the condition is false at the beginning. But in case of exit control, the body is going to be executing at least once, then it checks for the continuation, and it will exit from the loop if the condition is false at the beginning. So that is the difference between entry control and exit control. In any situation where we need to execute the body at least once, at that particular situation we are going to use do while loop, and for any other situations we can use for or while. Also, there is another criteria. So for is sometimes used when we have countable number of iterations. That means when we know that how many iterations are going to happen at that situations, for is preferable than while. I'm saying preferable, I'm not saying for is applicable. Preferable in the sense while can also be used in that particular situation, for is more suitable for that particular situation. And when we don't know the how many number of iterations are going to happen there at that particular situation, while is very handy. So let's compare all the statements while, do while, and for, and also check for that beginning. At the beginning, as I said, initialization statements, binary condition, body of the loop, and state value. So this four actually forms the part of the loop. So these four stages or these four expressions together forms a loop. So as we can see, so there was initialization. Then we had body, then condition, and the state value. So I am just writing it down for your reference. So we have these four parts, and we are going to check whether where these four parts lying in case of while, in case of do while, and in case of for. So that's why we are learning these three loops all together, because it will be very much helpful. So in case of while loop, we have initialization step at the beginning. Then we use a keyword called while. Inside that we put the binary condition, and this while becomes a block, and in that particular block we have the body of the loop, and also we have the state value. So this is the syntax of while loop, where in case of do while loop we don't have the condition at the beginning. So what in do while loop happening? So we first initialize the step. So that means this is 1. So if we number it body 2, so this will be 2, this is 3, and this is 4. So in case of do while loop, what is happening? Initialization is at the first, that means 1. So then it is 2 body, then step value is 4, and then condition checking. So this is what happening. So we have do and while, these two keywords, and within this do block we have the body and the step value, and while is proceeding do this do block with a condition. So what is happening here? So we are going to just look into the for first, then we will come back here as well. So in case of for, we have all the statements in a single line. So we have initialization here, we have body here, we have binary condition here, and we have state value here. So this is the organization. So we use this for keyword for loops, and this is the organization of this initialization, body, condition, steps. So now look at what is happening and what is the control flow in this particular loops. So in case of while loop, what it does? So let me clear the screen first. So what is happening in while loop? So first the control comes into initialization step. So this is the first step. Then it checks for the condition. So this is the second step. So if this condition is true, it will move into the body. That means this is the third step. And after executing whatever statements are inside the body, it will move towards the step variable change or a step value change. That means it will update whatever value is being initialized in this initialization step. Now this is the fourth step, and from this fourth step it will move back to this binary condition. So this is the fifth step. So when this binary condition is true, that means this is yes, this number three steps will be executed. If the binary condition is false, so it will move out of the loop. So if this is false, that means if this condition is false, we can move out of this loop. That is the sixth step. So this is how the control flows within a while loop. That means it comes to initialization, it checks for the binary condition. If the condition is yes, uh, it will execute the body, then it will execute the step value. Afterwards it will execute the condition again. If the condition is true again, it will again repeat the body and step, and it will move to the condition checking. If the condition is true again, it will repeat body and step. And this is how, until and unless this condition is true, this body and step value is being repeated. And when for the first time this binary condition is false, the control will move out of the loop. So if at the beginning, that means after step 2, if the condition is false, then also this loop or the body will not execute. So let's come for this particular for loop. So here also first initialization step, then we move into the binary condition, that is the second step, and then from that we move into the body. So after executing body, so obviously if this is yes, this if this binary condition is yes, or if this binary condition is true, then only we are going to execute the body. After that we move into this step value change or step value. So this is the fourth step, and from there we move into the binary condition. So this is the first step. So as you can see, maybe the organization of this initialization, binary condition, step value, and body are different from while, but the control flow is same. Here also we move into initialization, then condition, then body, step value, condition, and then false. If the condition is false, we are going to move out. So similar thing is happening here. Initialization, condition, body, step value, binary condition. If this condition is false, we are going out of the loop. So if this condition is false, we are going out of this loop, and this is the sixth step. So these two are entry control loop. That's why they have the similar principles. While this do while loop will be different. So what is happening here? So we move into this initialization statement. After that, we move into the body directly. So the next step after initialization, the next step is body. Then the step value is being updated. So this might be 3, and then we have this condition checking. So this is the fourth step. So what is the difference here? In case of while and for, we after initialization we move to the binary condition, but in case of do while, we are actually moving from initialization to the body and the step, then we are going to going moving into the binary condition. So if this condition is true, what is happening? We are moving into the body again. So if this condition is true, so this is the fifth step, and if this condition is false, so we are actually moving out of this loop. So this is how do while is different from any entry control loop. So from here we can see that do while is a exit control loop, and if this condition is false, we are moving out of the loop. If this condition is true, we continue for the next iteration. And what is different here? The difference is after initialization we are going to execute the body. That means even if the binary condition is false at the beginning, this body is going to be executed at least at once. Okay, so this is the working of while, for, and do while loops. Now take a look at some example of this particular loops, and we are going to use the similar example that we have shown in case of showing different parts of iteration. We have same set of statements, but the sequence is different, just nothing else. So this is the initialization, this is the condition, this is body, and this is the state. So this four parts is there. Similarly, the organization is different, but they will all produce the same output. So while A is equal to 1, A is equal to 1, that is the initialization statement. In case of for as well, A is equal to 1 is the initialization statement. In case of do while as well, A is the equal to 1 is the initialization statement. And all these loops, though their orientation of in initialization, condition, body and step is different, they works same and they will produce this similar output for this particular example. Now we have two statements or two basically keywords, break and continue. So break B will be small and continue C will be small in case of, so as you can see, break and continue, they as they are keywords and C++ is a case sensitive language. So B and C are small. So break, what it does, it uses to break out of a loop or a switch case. So we have already seen how break can be used in case of switch case, from where we can break out of a switch case. Now we are going to see how break works in case of loops. So we have taken a while loop as an example. And also one point to be noted, break doesn't work on if else. That means you cannot break out of if else using break statement. One continue, it actually skips some iteration. So it is used to skip some iteration in the loop. It doesn't work anywhere else. Continue only works on loops. So it might be while, for, or do while, doesn't matter. So it works on loops. So let's look at this particular example. So what we have A is equal to 1 and we have while 1. Now this is interesting. So what I said that anything non-zero is true. That means while true is true and we are not changing. So this is a constant 1. So constant means we are not changing any value. That means this control variable, so there is this binary condition doesn't contain any control variable. So if this condition doesn't contain any control variable, what is happening, it is a constant truth. That means 1 is always true. That means this becomes infinite loop. So this while one is an infinite loop. That means it will go on forever. For that, we have used a break statement to break out of this loop. So what we have done, or what the modification we have done, so we want to print 1 to 10 again. And similarly in previous examples as well. So we have initialized A is equal to 1. Now we are printing the value of A and we are going to increase the value by 1. So this particular set of statements is going to execute repeatedly, and when A becomes 11, at that particular time, this particular condition A greater than 10 will be true and it will break out of the loop. So that means A10 will be printed. So when the value of A is equal to 10, the 10 will be printed. And then what will happen, so A will increase by 1, so A will become 11. After that, as 11 is greater than 10 is true, it will break out of the loop. So this is how we can break out of a loop or out of an infinite loop using break statement. So you can use not necessarily whenever you are going to run or you are going to use if break statement, you have some infinite loop. You may have some other conditions to break out of the loop as well. And so this is how break works. And for in case of continue, what is happening, so it used to skip some iteration. So whenever you put a continue, rest of the statements inside the body of the loop will be ignored and the loop uh, will move into the next iteration. Okay, so what is happening here, so as we can see, we have initialized A is equal to 0 and also we have incremented the value of A by 1 at the beginning. So the increment now residing at the beginning. So the interesting thing is that the increment in the body might be different parts in case of while and do while loop, but they can be interchangeable. So the position can be interchangeable inside the body of the loop. So that's why I have increased the value A. Then if A is equal to 5, we just continue. That means when A is equal to 5, this particular statement is going to be skipped. Because of that, in this particular output, you can see 1, 2, 3, 4 and 5 is missing. Because When the value of a was 5, after incrementing the value, we just continue to the next iteration. That means it moves into the next iteration and a becomes 6, and then as a equal to 5 is false, we have printed 6 here. So that is happening here. So that's why 5 is skipped from here. So using this break and continue, you can upgrade or you can modify your loops very efficiently, and you can handle your loops very efficiently depending on certain situations. Now, let us discuss about input and output in C++. So we know that from C, printf and scanf were the methods that were used to print something on the screen and take some inputs from the screen respectively. Here we have two things. So one is the header file iostream.h. So we have to include this header file for input and output operations. And for that we have to use include std, sorry, not std, io string, not .h. So we don't have to put the .h for C++ header files. So we can include this as include iostream. And also we have to use this std namespace, because in this namespace the cin and cout are defined, and the name of cin and cout is resolved by this namespace std. So if we don't use this namespace, what we have to do in case of cin and cout, so cin is basically used to input something from the user or from the command line, and cout is to display something or print something on command line. So if we don't use the namespace std, what we have to do, we have to write std colon cin all the time and std cout. So they are called the scope resolution operator. So using this, we are mentioning that we are using the cin and cout from this std namespace. So if you don't use this using namespace std in your program, or in your program like this, what you have to do, you have to just use stdcin and stdcout. Uh, and it is a very good practice to don't include this std namespace. But for smaller programs, it is very fine for including this std namespace. So just take a look at this particular example. Int main, int a. So we are going to define or create a variable a, in which uh, we are going to take input. So scene A. So we have taken an input from the console. So suppose user has entered 5, then cout entered A. So the output will be entered 5, and it will return. So the as main returns int, we have the return 0 statement. So this is how you can take input and print something on the screen using cin and cout statements. A variable declaration is quite similar to the C syntax, but what advantage is here, variables can be declared whenever needed. That means we can declare variable wherever we want. We don't need to declare all the variables at the beginning of any executable statements like we used to do in C. And the syntax is same: data type, var name. So this syntax is same as C, but what is different here? Now we can define variables anywhere, wherever we want. There is no need to define all the variables declaration at the beginning of the program. So that's why this int a is a valid statement, as well as, so after executing cout enter a number, we have created a variable int a, or we have declared a variable int a. This is also a valid statement. That means we can define variables whenever we require. We don't have to initialize or declare variables at the beginning. So what this gives to the programmer, this gives the programmer the flexibility to declare variables anywhere and to remember them correctly. So you don't have to, if you are writing say thousands of line code, you don't have to scroll down and up to declare a new variable. You can just declare it whenever you require.
So that's the end of today's video.